Our next speaker will connect remotely again is Adrian Damaschin, Senior Software Engineer at GoPro Data Science engineering team. And he's a multi-domain professional with over 10 years of experience in different software development environments, passionate about cloud, data engineering, and analytics. He will discuss the reasons GoPro leverages Slack for metrics delivery, the Slack reporting architectures, how to leverage configuration and Apache Spark to automate the Slack layout and visualization. Adrian, I see you're already on, so you're ready for us. Thank you.
Okay, hi everybody. We're here to talk about what probably everybody is interested in. How can we easily see metrics that are coming from our data? And I'm going to tell you a little bit about how we're doing things at GoPro. So first off, we have the agenda. I'm going to talk a little bit about what is the GoPro data platform and the data science engineering department. What kinds of data do we have? What's our business use case, our data infrastructure? And the second part will be about the actual metrics delivery via Slack. Why do we choose Slack? What's our delivery framework? And then draw up some conclusion. So what is the data science engineering department here at GoPro? We're a bunch of engineers that are trying to handle every piece of data that's coming to GoPro from our devices, from our apps, from our third-party vendors, and so on. We have a big data lake infrastructure, and we're going to see how we productionalize data and how we deliver it to analytics. First off, we have multiple data sources. Everybody probably knows that data is coming from everywhere, like I said, from multiple angles. And here is where we take in the data. Our data infrastructure handles the incoming stream of data, processes it, and puts in the data lake. Then we do different data aggregation, different metrics generation, depending on whatever the data is used for. And we have a couple of uses for the data. First off, we provide data to the analytics team. This is the team after engineering that makes up all the beautiful graphs and Power BI tools, which provide business owners and product managers and even the senior leadership team with data, because we're trying to be a data-driven company. And for that, we need accurate data and accurate interpretation of the data. The second big project we have, we call it the CDP, Customer Data Platform, which we're trying to have a 360 view on all the customers that we have. Of course, behind GDPR regulations, so only people that agree. This provides marketing data. We're able to target clients better and see how they perform over time. And also, this actually provides more data. So we're handling the ingestion for that also. Going further, what are our data sources? So the first off, we have our applications. Mobile applications, desktop applications. We generate events with some third-party vendors. We generate events on everything that's happening on our mobile apps for usage purposes, for analytical purposes. The same goes for desktop. The second big source is our camera. All the camera models have integrated the event generation in their firmware. Whenever something is done with the camera, it records a small event in a local log. After that, everything gets pushed to our endpoints whenever we have the chance, whenever the camera gets connected to the internet or whenever we get through the cloud. Next up, we have e-com data, everything that happens on the website. How are we selling the products? How are users using our website and our e-com website? Our streaming services, the cloud, the S3 media access. We store all the users' media on S3 as part of their cloud service. And we have metadata related to everything from that media. And of course, marketing. I was talking about marketing, how users respond to campaigns, to emails, to mobile campaigns and pushes, app pushes, and so on. And then there is the backend data, which is the purchase records or subscription records. How are people reacting on social media, and so on. We're trying to gather everything about related to the GoPro brand, basically. Data infrastructure and business support areas. What data infrastructure do we have, and what areas do we support in the business? So the first stop is the data lake infrastructure. Basically storage, data discovery, operational databases, and computing infrastructure. The second is the BI and reporting for visualization, data quality management, how we display metrics. Here we're going to dive in a little bit further. Data product and services, the APIs that we maintain. We're receiving data on different APIs or endpoints, S3, FTP, so on. And the machine learning infrastructure that we're using for feature engineering, data quality, and end-to-end machine learning production. The support areas that we handle, like I already told you, the marketing for ad campaigns and CRM, customer data platform personalization of the data, the information that we display for them, the product analytics, how our products are being used, what features are being used, how are they used, and what are the most successful features that we have. And the business operation, like brand protection, GDPR, e-commerce, any legal issues that we need to handle are being handled here. So let's talk a bit about the architecture that we have. We talked about the sources. We have the GoPro app and the cameras and all that stuff. We have a REST API, FTP, S3 syncs, and also some external databases maintained as Amazon RDS. Everything needs to get to S3 as Parquet files in the data lake in using Hive Metastore. So how are they getting there? First up is the streaming part, which is usually active for the app and the camera. We're using Kafka to handle incoming streams of data. And then we have streaming ingestion that puts everything in the data lake. The file-based, the REST API, the FTP, S3 are handled by our big batch framework. So we're ingesting everything as batches using a big framework that we have and handling dynamic DDLs if anything happens. And for the existing databases, we're using Apache HBase, and we have a state sync for these. So everything ends up in our data lake. Then from our data lake, we push to different kinds of clients. We push to Tableau servers, Plotly, different kinds of notebooks we use in Databricks, Slack, or any other external services from our third-party vendors. So let's get into the points. Metrics delivery with Slack. So What are we referring to? First of all, if anybody is unfamiliar with Slack, Slack is basically a corporate chatting platform. So direct messages, groups are available, and also different kinds of channels. It's similar to Teams or other providers that we are using. So everyone is logged in. So this is the first advantage. Here's how a Slack delivery could look like. We generate, of course, some simple graphs with Plotly. They can be any kinds of graphs, like bar graphs or line graphs, or even area or pie charts. And we're sending different kinds of information. So for example, media volume to usage. We're checking how one of our tools is used. And sorry for hiding the numbers, but that's the policy. We have this split into three parts. So the first one is the actual number for this reporting period. And then we have the comparison. We have a percentage comparison between previous period and the current period. We have a trend like up or down, and we have the previous number also. This can be split into different categories. So for example, we have everything on the bar chart, volume, mute, boost, whatever the case. There's also this for showing history. We usually use graphs to show trends, like last 6 months or last year or something. So everything can be shown as graphs. We use the Plotly server for generating the graphs. As you can see in this small print screen in the middle, we actually use this a lot. So we have channels for basically every service and every product that we handle. So we're generating metrics on the go for most of the products that we have, and from all of the data that we have. So we're going to talk about a bit about the use cases and what can we generate using this. Coming back to the data sources that we had. So what can we generate for each one? For example, the apps, we can see how many connections we have, what are the features from the apps that are most used, what kind of video edits are the users doing, if they're logged in, if they're not logged in, are they using premium features or are they using free features? What kind of premium features are they using the most? Or what kind of category of premium features are they using the most? So we know where to improve, we know where to get. And there's also the second part where we can see the failures. Is the app having errors? What are the areas that the app is going haywire and what needs to be fixed? This goes for the GoPro app also. The second one, we have the camera. So what kinds of camera we have in use right now in the world, let's say. What kind of videos are they using? What kind of the modes that the camera is being used for? Are they using most for video? Are they using most for pictures? We need to improve on some kind of resolution. Is some kind of resolution not being used enough and we thought it was good, but it apparently is not received good by our customers. Then there's ecom. How much time are they spending on the website? What kind of accessories do they buy, or what kind of links do they form between the products? Where are they coming from? How are they using the streaming service? How are they using the media on the cloud? How much storage do they put on the cloud? As you well, we are offering free cloud storage, unlimited. So we need to know the cost of our cloud storage and what kind of access are we getting from them. Also the subscriptions, how many subscriptions do we have? We report these to SLT. They need to know on a daily basis if we have new subscriptions or not, what kind of transactions do we have, and how are users reacting to the campaigns, and do they respond, do they don't respond, and so on. So these are applications to short. As you can see, there's a lot of data to be driven from here. Also, like I said before, we also have the CDP platform that's actually aggregating data from all sources and sending reports from that. So let's talk a bit about why are we using Slack. We can be using a powerful BI tools, but we decided to use Slack. So the first advantage is the push versus pull. Metrics are already generated. So we have two methods of generating metrics. Either we generate them in the Slack report. So when the job for the Slack report is running, metrics get generated on the go from the actual data, and then they get pushed through Slack. The second one, which is used for more complex metrics, is generating the metrics in advance. So how does that work? We have a separate job that goes through all of the tables, all of the data sources, and generates the metrics and saves them in a metrics table. The metrics table then gets also delivered to the analyst, so they can slice and dice metrics however they want. And the summary of the metrics gets pushed to Slack. Also, the same metrics may be pushed through different kinds of BI tools. So they can get visualized and sliced and diced in a more powerful visualization app. A second advantage is that we are avoiding another login to view metrics. So Slack is already connected for everyone. Everybody is connected at all times, either if they're on their laptop, their desktop, or even their mobile. So whenever the Slack message gets pulled, the user is already logged in and can view the metrics as a result. They don't need to make a request. They don't need to log into a different app or anything else. Like I said, it's easily accessible via mobile devices. So anywhere you are, you can see the metrics. The second big advantage is the fact that we moved away from any Power BI tools dashboard, and we have the metrics generation inside the software engineering process. This means that SQL code is under strict software control, is versioned, it's always the same, it doesn't get lost, it's used for the same generation over and over again. So we don't have issues of difference in numbers because of somebody selecting something different in a Tableau or a Power BI. The publishing job is scheduled and always comes at the same time. Performance is monitored, so even if something fails or we have a disaster recovery process that engineers step in and they can fix the job and the job gets pushed anyway. We also have a direct chat that we can use since these are pushed through a simple channel. The right people are already there. They can have questions, they can make comments, and we actually use this for review. We design special review channels that we push metrics before we send them to production. The right people look at the metrics, see how the metrics work, look for any kinds of bugs or misunderstandings or missing metrics or extra metrics that they may not use. And we directly chat in there. Nobody has to set up a different meeting or something like that. There's also the easy access management that can be provided not just by IT or the dedicated service. It can be provided by any Slack user. So every channel has, every private channel in Slack has an admin, and it's invite-only access. So only the right people involved in the actual metrics on the actual subject, get to invite new people and see who's actually viewing the metrics. There's also the advantage of having daily metrics. So I talked about different reporting periods. The reporting periods can vary from actual quarters or monthly. We usually use monthly and weekly, but there's also daily. So we actually get another advantage from that, which is quick monitoring. So we see the result of our data every day. The product managers usually notice anything weird that's coming in from the data, and we can react fast before we get months worth of data or anything. Everything gets daily metrics. And we also have the metric consistency. So we are avoiding ad hoc metrics that are generated by different teams with different numbers. We are the software engineering process generates the metrics, stores them in the table that I was talking about, and all the teams get access to that table. So everything everyone is using the same metrics. They're not working with different numbers or with different definitions. Going further, we have a bird's eye view on the Slack delivery framework. So we either have a simple Slack Spark job, or there's a generation job behind that. But the same Slack Spark job pulls data from a table, either being a metrics table or being a data table. We make the metrics, we generate them as JSON. We push a message to the Plotly server that with a query and with data. The Plotly server generates the graph that we saw in the first few slides. The graph then gets stored on S3, and then everything is combined together as JSON and is pushed to Slack as a JSON message. Slack offers an API with what they call webhooks. The webhooks are individual channels APIs. So everything that gets pushed to that API is published into the individual channel. This is how we actually go. All of our jobs are following this thread, let's say. Everything is config based. So we don't have multiple jobs. We don't have Spark jobs or written code for everything. We just have a single Spark job code that knows how to read the config. And based on the config, it pushes everything and generates everything into either the Slack channel or the metrics table. So let's take a bit of a dive in how is this config organized. So let's say we have a Slack plus push weekly. Do we have persist metrics? That means we need to save them or not. Then we have the channels that we are posting to. So we're posting here, let's say, to plus metrics or NDSC metrics test. So we're both posting to a review channel and the production channel. And this is how an API from Slack actually looks like. And there's a big string here. Then we have the metrics groups. We may have multiple groups that get sent as different messages, or everything in the same group gets sent as a single message. So you can have even 30 or 40 metrics in a single group that gets sent, or we can have them split into separate groups that have different titles and so on. And we have a template for this that I've showed you in the previous pictures. There's also another detail here. Here we have the individual metrics. So here are, that are part of the group. We have the attachment title, we have the metric period, we have all the display chart style attributes like what colors to use comparisons or not. And we have three main queries, let's say. The first one is the actual query that's pulling the data. The second one is the compare query. So we're comparing different kinds of two periods. So we're looking at the current period, and the compare query needs to pull the same data from a previous period. And then we have the chart query that is used to generate the chart. This usually is over 6 months or 1 year, like I said. This is configuration driven. So we can design a configuration like this and just use the job, and we have a new Slack push that we can use. We can have multiple private channels for mobile cloud subscriptions, web sales, or whatever. We can have any kind of interval for comparison, either daily, weekly, monthly, quarterly, even yearly, although we don't use them. And new metrics can easily be added to this config just by having a new SQL for the metric. So you just add another section for this, like another weekly capture users by region or something, and a new Slack section in the message gets generated. So let's draw some conclusions. What are the pros and cons for using this? Like I said, we have quick and easy access via Slack. Everybody is connected at all the time. They don't need a second login. They can use it's multi-platform. Slack is available on both desktop and mobile. The graphs get generated in a different app and then just get pushed as pictures. So you don't need a desktop app or Power BI tools to actually view the graph, to view the trend, to view anything. You can just see it as a picture on your mobile device. We can deliver metrics to everyone, to engineering managers, to executives, business owner, or even product managers. Everyone in the company is connected on Slack. So everyone can view the metrics when they are generated. They don't need to go into a different kind of app. They just get a message on their mobile device, which gets pushed, and they can view the metrics. They don't need to go and execute the query or wait for a graph to load or whatever. Everything is config based, so metrics are easily added, modified, deleted, and everything is managed by the software engineering process. This offers a lot of maintainability, and we have versioning for this. So we can look in how the metrics changed over time because everything is in GitHub. We can see any errors that we can regenerate history because we also have jobs for generating bigger amounts of data for the last year or more. So whenever a metric definition gets changed or a bug is found, the query is changed, and then everything gets regenerated, and we have the new numbers which are up to date for the whole period. And there's easy access management that can be done by the channel owners. Nobody needs to set in a ticket with IT. They just go into their Slack. Hey, I need to have access to that. And the Slack owner just adds the person to the channel. But there's also some cons. We have a Slack UI limitation. We can only display summary metrics. So this is not really useful if you want to slice and dice metrics like interactive graphing and so on. The graphs are generated before the message gets pushed. There is a single graph, so you are not it's not possible to change the graph or anything else. There's that 2-column format that I was talking about. So when having multiple group bys or something like that, the Slack message may get overwhelmed or overflooded. And graphs are fixed size, and like I said, not interactable. For a more complex data exploration and visualization platform is needed because even though we're offering as much information as we can, still a summarized information. So if anyone needs to slice and dice, we have other applications for that. For example, we are using supersets for that. And every Slack message that we have also has a detailed version which is in superset. So everything in Slack, we also send in the link to that dashboard. So if somebody needs different kinds of information, they look at the graph and want to see, hey, I'm looking to split this or looking for different kinds of information, then they just can access the superset and they are looking at the more detailed graphs for that. So I think this about covers it. If anybody has any questions, I'm free to take them.